Hello and welcome to today's lesson. We're going to be covering topics under the standard 3.3 in Algebra 2, and then also we're going to be going over questions in the Study Island lesson, sequences and series. So remember, as you're going through, please be taking notes so that you have something to refer to, and if I go too fast, just pause and rewind so you can stay caught up. And the main thing we're going to be looking at is when you see these questions in Study Island, they give you a table. And that table talks about nth term and sum and geometric and arithmetic series. And so how to tell the difference between all of that and which formula you need to use for each problem. Because once you know the formula, it's just a matter of substituting in the information you're given and you're good to go. So I'm so glad that you're joining us, and let's go ahead and look at some notes.
The first vocabulary word you're going to see in these problems could be arithmetic sequence. And so what this is it's a sequence, or you can think of it as a pattern, where there's a common difference between any two terms. So here's an example. These are going up by 4, so that there's a number you can add or subtract from the term before and keep repeating that to get the pattern. And if you make this a series, that just means that you're taking the sum of however many terms it tells you in the problem. So it could tell you, what is this series through 8 terms, and then you would add up the first 8 terms, and that would be your answer. And so here's an example here where they're adding the first 5 terms. Another vocabulary word you might see is geometric sequence, and this one has to do with a pattern where there is multiplying. So here, the ratio of this example here is 3. So that means if you multiply each previous term by 3, you get your next term. So here, 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, and so on. And you could even do it, negative half. So negative 1/2 times 64 is negative 32. Negative 32 times negative 1/2 is a positive 16, and so on. And then once again, when you make it a series, you're adding however many terms it tells you to create the series. So here, this one's being multiplied by half, and they added the first 5 terms. This question here asks, what is the value of the 7th term below? And so it gives you the first 5, so you could find 6 and 7 following the pattern. And so looking at this, I see it decreases by 5 each time. So that means because it's decreasing or increasing by the same amount, that's going to be the arithmetic series. And so in order to find the 7th term, I'm going to use this first formula. You could, like I said, you could also work it out, but I'm going to show you how to use the formula. So the formula says to take the first term, that's what A1 means. So the first term here is 5. So I'm going to take 5 plus parenthesis. N is the number term we're looking for, which is 7. So 7 minus 1 parenthesis times D. And D is the difference. So since they're going down by 5 each time, this is going to be a minus 5. So then I just follow order of operations. 7 times 1 is 6, times negative 5 is negative 30. And then I add 5 to that, and that's going to be negative 25. So that means negative 25 is going to be my 7th term, so my answer is A. This question here asks, what is the value of the 8th term in the sequence? And so you could, figure out the pattern and work it out, but sometimes the numbers start getting really big, or they ask you too far out for it to be time effective to work it all the way out, and you could make a lot of mistakes. So I'm going to figure out, is this pattern created by adding or subtracting something, or by multiplying something? So each time I'm noticing the number doubles. That means I'm timesing it by 2. 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56, and so on. So if I want to find a certain term, I'm going to use this top formula. It's for the geometric sequences, since it's a multiplying. So here, A1 once again means the first term, which is 7, times the ratio number, which is what you multiply each term by. So since I'm multiplying by 2, this is going to be times 2. And then n, I'm looking for the 8th term minus 1. So this is going to follow order of operations. I do parentheses first, and then I'm going to do exponents. So 2 to the 7th is 128, and then 7 times 128 is 896, so that makes my final answer B. Okay, this problem takes some algebraic thinking. I know that a to the 4th is 10, or the fourth term in this sequence is 10. The 6th term is 52, and I want to know what could the common difference be. So right off the bat, I'm going to think, okay, I know a to the 4th is 10. Well, I know a to the 5th is going to be a to the 4th term plus the difference. But since I already know that a to the 4th is 10, I can just write it as 10 plus whatever difference I'm looking for. And then a to the 6th is going to be 10 plus the difference again. But I also know that a to the 6th is 52. So this is going to be 52 equals 10, and then d plus d is 2d. And I can go ahead and solve this. So I'm going to have to subtract 10 from both sides. 52 minus 10 is 42. So 42 equals, these 10s cancel, so it equals just 2d. Divide both sides by d, and d equals 21. Okay, this question here, we are given the geometric series here, and I want to know what is the beginning value, the value of b. So what you could do is you could use this first formula here where it's talking about the number of terms, and you could just solve for a1. Or you could think about it, okay, I need to find, for either one of these, I need to find what is being multiplied by each time. So if I look at it, the top stays 7. So 7 times 1, 7 times 1, 7 times 1. So that means it's the top of the fraction is being multiplied by 1. And if I look at the denominators, it's 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So the denominators are being multiplied by 3. So as a whole, each of these fractions is being multiplied by 1/3 to get to the next term. If you want to go backwards, the opposite of multiplying is dividing. I'm going to divide 7/3 by 1/3. And so you could just use your calculator to do that, or you could use your fraction rules. Remember, when you are dividing fractions, you actually flip or the second one and multiply, or multiply by the second reciprocal. So here, 7 times 3 is 21. Over 3 times 1 is 3. 21 over 3 reduces to 7. So that means the first term here is 7, and my answer is D. This asks us to find the sum of the first 8 terms in the following series. So we have to decide, are we going to use the arithmetic sum or the geometric sum? And so I'm looking at this, and it looks like it's being multiplied by -3 each time. So that means because we're using multiplication, we're going to use geometric. So, and we're talking about the sum, so we're going to use the geometric sum formula. And so it tells us to take the first term, which is -3, times, parentheses, 1 minus the ratio, which is what you're multiplying by, which is -3 here, raised to the n power. N is the number of terms you're adding. So we're doing the first 8 terms, so this is going to be an 8, in parentheses. And then that's going to be over 1 minus, and then once again my ratio is still -3 because that's what I multiply each term by. And then I just simplify this. So looking at the top, I'm going to do exponents first. -8 to the, -3 raised to the 8 power is 6,561. So that's going to look like this. And then on the bottom, 1 minus a negative 3 is the same as adding 1 plus 3, which is 4. Then in the numerator at the top, I need to continue using order of operations. So I'm going to do parentheses next. 1 minus 6,561 is going to be negative 6,560. Then I'm going to do the multiplication on the top. And negative 3 times negative 6,560 is positive 19,680. When I divide that by 4, I get 4,920, which is answer A. This problem here gives us a geometric series with the first term negative 4, the common ratio is 5, the sum of the series is negative 624, and I want to know how many terms are there in this geometric series. Well, right away I see I'm talking about the sum of a geometric series, so I'm going to be using this formula right here. But I also noticed that they already give me the sum, and I'm going to be solving for n this time. So it's going to look a little bit different. So first thing I'm going to do is just substitute in all the values I know. So I know the sum of this is negative 624. And that's going to equal the first term, which they told me is negative 4. And it's going to be 1 minus, and my ratio is 5. And then I'm to the nth power. That's what I'm looking for. And that's all over 1 minus, and then the ratio again is 5. So I'm going to simplify this as much as I can. The first thing I can do is subtract the denominator. So that's going to be negative 4 in the denominator. And then I see that there's a negative 4 in the numerator and the denominator. There's multiplication here by the one in the numerator, so that means I can cancel these. They're going to divide to 1, which cancels them out. And so that means I'm left with negative 624 is equal to 1 minus 5 to the n. I want to continue to get my term with n in it by itself. So I'm going to subtract 1 from both sides. And that gives me negative 625 is equal to negative 5 to the n power is what that's equal to. And so anytime I have an exponent is where my variable is, I need to use the logarithm to remove that. So I'm going to, and the logarithm that you choose is the bases have to match. So here my base of my power is negative 5, and so I say, oh, well, I can't quite do that yet because these are negative. So the next thing I'm going to do is divide both sides by negative 1 or multiply both sides by negative 1. Each way works. And that's going to make it so I have a positive equation to work with. So I can take that logarithm. So I'm going to have 625 equals 5 to the n power. And now I look and say, okay, my base is positive. So I'm going to go ahead and take the log base 5 of both sides. And so this you can put into a calculator, or you can think 5 raised to what exponent gives you 625. Well, 5 to the 4th power gives you 625. So that's going to be 4. And then here, this all cancels out and I'm left with n. And that was my goal, is to get it down to n. So this is my answer. B. This question here says the Reed family bought a home 11 years ago. The home has appreciated 5% annually. So that means the value of the house has gone up 5% every year. So if their home is currently worth $181,296, approximately how much did they originally pay for the house? So when you're dealing with interest, you can, or percentages, you can multiply the original amount times 105,000 in this problem to find the new value. And what that's saying is the new value is 100% of the old value plus a 5% appreciation. So that's why we're dealing with the 105%. So that's going to be my ratio because I multiply every new value every year by 105%, which as a decimal is 1.05. So that's going to be my ratio. So then they want to know what is the beginning term. So I'm going to look at this formula right here. I know that the last term is going to be 181,296, and that's going to equal to A1, what I'm looking for, and then my ratio is 1.05, and then this was the 11th year, so that means it's going to be the 12th number. And the reason for that is the first term is actually what it was when they first bought it, before any time passed. So the first term is actually year 0. And then the second term is year 1. And then the third term is year 2. So that's why you have to go one higher. So it's going to be 12 minus 1 for your exponent. And then I go ahead, that's the first thing I'm going to do is those parentheses, 12 minus 1 is 11. And then I'm going to take 1.05 to the 11th power, which is 1.71. And then I just divide both sides by 1.71. And when I do that, I get 106,021, which, when you're rounding, because it says approximately, that's going to be the closest to my answer choice B. Thank you for joining us today, and I hope you learned something new.